We're going to discuss different methods in order to solve linear systems 3 by 3, 3 equations, 3 unknowns. Now, as you can see here, we're starting with the substitution methods, and these are the different steps in order to solve a system 3 by 3 by substitution. Now, we're going to go through these steps in details through this first example. So we have this system 3 by 3 that we need to solve by substitution. Now, similarly to solving by substitution systems 2 by 2, usually it would be easier to look for variables with 1 or -1 as a coefficient in order to avoid substituting an expression with a fraction. So over here, if we call these equations E1, E2, and E3. So the substitution method, step 1, consists of writing one of the variables in terms of the other two. So as I've already mentioned, I try to look for a variable whose coefficients 1 or -1. For example, if we look at the third equation, I can, for example, write x as 6 minus y plus z. So this is x written in terms of the other two variables. Now, and what I do here, the next step would basically consist of replacing x in the other two equations by that expression in terms of y and z. So, in E1, when I replace x by 6 minus y plus z, I end up with 12 minus 2y plus 2z, since x is multiplied by 2 at E1, plus 4y plus z equal to 5. And I simplify this into 2y plus 3z equal to -7. So this is my first equation in y and z. Then doing the same thing for E2, replacing x by that expression would lead to 3 times the expression of x, that's 18, minus 3y plus 3z, minus 5y minus z equals to 4. Then simplifying this, I end up with -8y plus 2z equals to -14, which you notice we can divide by 2 or -2. So dividing this whole equation by 2 would basically give me, by -2 in fact, 4y minus z is 7. So as you can see here, by replacing x in E1 and E2 by its corresponding expression in terms of y and z, I ended up with two equations in y and z. So basically the system 3 by 3 was reduced into a system 2 by 2 in y and z. So all we have to do now is just solve this system of simultaneous equations in y and z. Now you could use any method you feel like doing. Now over here, when you actually solve the system, you would get y equal to 1 and z equals to -3. I assume you all know how to solve systems 2 by 2 at this point. So now that you have actually solved the system, now we go back to the expression of x in terms of y and z and replace y and z by their values. So x in fact be 6 minus 1 minus 3, then x is 2. So the solution set of the system is basically the triplet x, y, z, which is 2, 1, -3, but of course it's a set. This is one element in a set, so we have to put it in fact in braces, or you could just give x equal y equal z equal as your final answer. You don't really have to write a solution set anyway, but if you were to write a solution set for the system, it has to be the triplet x, y, z inside braces. Now, if we move to the second method, which is the elimination method, of course, these are the steps for elimination method explained, which we will go through in the following example. Now, again, by calling these equations E1 and E2 and E3, you notice that this is the same system we've solved earlier by substitution. We're going to solve the same system again by elimination here. So, the elimination method consists of fixing one equation as a first step. For example, here if I fix equation E1. So, by fixing E1, I'm not allowed to touch it, E1, until I finish solving the system. So, I fix the first equation, and then I use that fixed equation to eliminate a variable, the same variable from E2 and E3. Now, you notice that since in E1 we have a plus z, and in E2 and E3 we have a negative z, so in that case z is the easiest to eliminate. So over here I'm choosing to eliminate z from E2 and E3 using the equation I fixed, which is E1, and that's of course using linear combinations. So over here I eliminate z and E2 by adding E1 and E2 together. So by adding E1 to E2, we end up with 5x negative y equal to 9. Then I eliminate z from E3 using the fixed equation as well. So E1 plus E3, by adding E1 and E3 together, we get 3x plus 5y equal to 11. So as you can see, these two linear combinations left me with a system 2 by 2 again. 5x minus y equal to 9 and 3x plus 5y equal to 11. By solving this system 2 by 2, of course, you could do it yourself. By solving the system 2 by 2, we end up with x equal to negative 2 and y equal to 1. Then I go back to the equation I fixed and replace the obtained values of x and y in E1 and find z. So which leaves me with, so using E1 now, 2x, so that's a negative 4, plus 4y, so that's a 4, plus z equal to 5. I'm sorry, x should be 2. Okay, so x should be 2, not a negative 2 when you solve the system 2 by 2. So therefore, this is a plus 4. Then z would in fact end up being 5 minus 4, which is negative 3. Now the solution matches the solution of the previous example. So again, the solution set of the system is the triplet 2, 1, negative 3. Now if we move on to the third method, which is called the method of Gauss. Now this method consists of writing the system in triangular form. Now, what does triangular form means? Writing the system in triangular form means that the first equation must include 3 variables. The second equation must be changed into containing 2 variables, and the last equation must be changed into containing 1 variable. So, as you can see, this way, which as you can see in this form here, this equation has a single variable, this one has 2, this one has 3 variables. So you can see that whenever you do so, you have changed the system or wrote it in triangular form. Now, why is it that this form would help us solve the system. Because if you look at the third equation, now since the third equation is an equation in Z only, then I can find Z. Now once I find Z, I move to the second equation, which includes Y and Z. Now that I have Z, I can find Y. And then, now that I have Y and Z, I move back up to the first equation, which contains the three variables, and now I can find the third variable. Now, the variables don't necessarily have to be this way in the triangular form. And the second equation does not necessarily have to include Y and Z, and the third equation does not necessarily have to include Z. What matters in the triangular form is for you to basically write the system in three equations where one contains three variables, the second one contains any two variables out of the three, and the third one contains any variable out of the three variables. So let's, over here, these are the different steps into changing the system into triangular form for the method of Gauss. Now, we're just going to move on to the example and see how it's done through this example, which you can also see it's the same system we solved earlier. So we're going to solve it again using the method of Gauss. Now, over here, by calling the equations E1, E2, and E3. Now, the method of Gauss and the elimination method, basically their first step is similar. So their first step consists of fixing one equation, which is the equation with the three variables in the triangular form. So basically, as you will notice, that the first step is the same as the first step in elimination method. So over here, we start by fixing the first equation. Then we need to use that fixed equation in order to eliminate a variable in E2. Now, as you can see again here, that Z is the easiest variable to eliminate in E2 using E1. So, and we do so by adding E1 and E2. So E1 plus E2 would basically give me 5x minus y equal to 9. Similarly, I eliminate the same variable in E3 using E1, the fixed equation as well. So that's E1 plus E3, which is 3x plus 5y equal to 11. So as you can see, up to this point, it's similar to the elimination method. Now, the difference here is that the elimination method would basically, from this point, takes these two equations, form a system 2 by 2, solve them, and then use the fixed equation to find E1, which basically the method of Gauss is almost similar here, it's equivalent, but in fact what we do to basically write it in triangular form is to basically, if you write the system, how the system became, it's 2x plus 4y plus z equal to 5, which is our first fixed equation. Then we have 5x minus y equal to 9, and 3x plus 5y is 11. Now, as you can see that I already have the first equation in 3 variables, the second equation in 2 variables. So what I do is, basically this was E1, let's just call this E4, and this E5. So in order to finish writing the system in triangular form, I need to write the last equation, E5, in terms of one variable. So over here, I need to choose one variable to eliminate from E5 using E4, not using E1, because if you use E1, the variable you already eliminated would reappear. So over here, using E4, I notice that if I multiply E4 by 5 and add it to E5, we would basically eliminate Y. Okay, so over here, 25 plus 3, that's the 28x equal to 45 plus 11. That's a 56. So x is 56 over 28. So over here now my system became 2x plus 4y plus z equal to 5, 5x minus y equals to 9, and then x is 2. So now my system is written in triangular form. From this equation we have x equals to 2. We replace it in E4, and then we solve for y. We should obtain y equals to 1, and then we replace x and y by their values in the first equation, and we should obtain z equals to -3. So the solution set would basically be containing the triplet 2, 1, -3.